Hey everyone, so today we're going to get started on review of Unit 2 Quadratics so that you're prepared for your test. So we'll take a look at the first problem here. We have 3x squared minus 6x minus 24. We need to figure out what we can factor out as our GCF. Here we would want to divide everything by 3, and when we do that, the 3 would come to the outside of the parentheses, and then we would divide each value of a, b, and c by 3. Once we do that, we're taking a look at our set inside of the parentheses. We have 3 terms. We need factors of -8 that add up to -2. What are 2 factors that we can multiply that get us -8 and add up to -2? That would be -4 and 2 here. Because we know that, we can fill in our parentheses as x minus 4 and x plus 2 because it fits both criteria. So that's your first example. Taking a look at the second problem, we would notice that we have 2 terms instead of 3, and we have a difference of squares, difference of perfect squares. This means we have to take the square root of both terms, and then we would add 1 and subtract 1. The square root of 36x squared is 6x, so that goes in the first term for both. And the square root of 49 is 7. We would add 1 and subtract 1. For our third form of factoring, we are looking at a equals 1. There's no number in front of the x squared. So we need factors of -28 that add up to positive 3. -28, we can multiply 7 times 4. And since we have a positive 3 here, the 4 would have to be negative. So we would get x plus 7 times x minus 4. Now we're going to turn and look at axis of symmetry, vertex, etc., parts of the quadratic that we would need to know, okay? The axis of symmetry, or AOS, can be found by first identifying what type of quadratic you have here. Here, we have a standard form. That means that x is equal to -b over 2a. Our a value is -2. B is 8, and C is 4. We only need our B and our A value. So to figure this out, we would plug in negative of B, which is 8, over 2 times A, which is -2. We always want to multiply down here first. -8 over -4 gives us a positive 2. Here, we're trying to look at the vertex. So when we're finding the vertex, we need to figure out the form. This is intercept form because we have 2 sets of parentheses. We have A, which is 3, P changes the sign, which is 3, and Q, which is -5. We are going to find the axis of symmetry first, and the formula for that is P plus Q divided by 2. Our P value is 3 plus -5 all over 2. That gives us -2 over 2, so our x equals -1. Now I would go over and look at our sets of parentheses. -1, the only x value that is -1 is right here. You could also prove that by plugging in -1 for x. When you do that, you would get 3 times -4 times 4, which does in fact give you -48. Here's another problem where we're expected to find the vertex, but we need to figure out what form this is. Since there's parentheses and it's squared, we know that this is vertex form, which means we have an A value, which is -2, an H value, which is -5, and a K value of 6. Our vertex for vertex form is H comma K. So all we'd have to do is get our two values and substitute them in. Solutions for the quadratic. Remember, solutions are also x-intercepts, roots. So we can figure this out by identifying the type. We have this in intercept form, which means our intercepts are given. They are our p-value and our q-value. Remember, we change the signs. P is 7 and q is -3. And then you would just find the correct answer there. For the axis of symmetry, again, we need to figure out the form. We've got standard form here. There's no parentheses. We would do x equals -b over 2a. -b is -10. 2 times 1 simplifies to -5. Okay, this part is where you're expected to show every single step. So we would type everything in here. The first thing you would want to do is divide everything by 2 because that's your greatest common factor. So if I divide everything by 2, the factor of 2 comes out, and I'm left with x squared minus 16. That's a difference of perfect squares. Square root of x squared is x, and the square root of 16 is 4. So we would add 4 and subtract 4. Then all we would do is set our two terms equal to 0 and solve for x. Subtract 4, you get x equals -4, add 4, you get x equals 4. We'll complete another problem like this, but this is factoring when a is greater than 1. So we have a, b, and c. We have a and c, which are 10 and -3. So we need factors of -30 that add up to our b value, which is 13. We would know that our bigger term has to be positive, so 15 times -2 is going to give me 30, but also add up to 13. We would then split our 13x to be 10x squared plus 15x minus 2x minus 3, and set that all equal to 0. To factor this out, we would draw a line down the center and divide the first two terms by 5x and the second two terms by -1. When I do that, you should get the same thing in parentheses. 10 over 5 is 2, the x squared over x is x. 2x plus 3. When we divide out a -1, we still get 2x plus 3. So that means our two factors are 5x minus 1 and 2x plus 3. We would set both of those equal to 0. And solve for x. To solve for x, over here you would get 1/5, and over here you would get -3/2. We'd add 1, divide by 5, subtract 3, divide by 2. Okay, This one's a little less work because we need to find factors of negative 45 that add up to 4. 9 and 5 will work. Negative 5 because 9 minus 5 is 4. So you get x plus 9 times x minus 5. And that's set equal to 0. So set both equal to 0 and solve. X equals negative 9 and x equals 4. Okay, now we would be rewriting these functions into standard form, okay? So in order to do that, we're going to break everything down. Let's start with the first one. Y equals negative 2 times the quantity x minus 3 squared minus 12. We are going to expand because there's 2 x minus 3's. Then we would FOIL. The negative 2 remains out front. First times the first is x squared. Outside, negative 3x. Inside, negative 3x. Last term's plus 9. All minus the 12. We would distribute the negative 2. So we get negative 2x squared plus 6x plus 6x minus 18 minus 12. When we simplify, we get negative 2x squared plus 12x minus 30. All right, the axis of symmetry here is pretty self-explanatory. We are looking at the h value. Since h is positive 1, then x equals positive 1. Now we can identify the vertex. We need h comma k here. We already know that the h is 1, our k is 3. Then for 15, we would go in and we would plug each of these values in to find the y value. So when I plug negative 1 in, you get y equals negative of negative 2 squared plus 3. That gives me negative 4 plus 3, which is negative 1. If I plug 0 in, I get negative 0 minus 1 squared plus 3, which simplified gives me negative 1 squared plus 3, which is then negative 1 plus 3. So we get 2. We know our vertex is 1, 3, and then we also know that the signs should mirror each other. So that's how that would work. Okay, so finally we would want to use the correct graph for that set of terms. So we used that previously with our points. We know that the vertex should be 1, 3. So this vertex is 1, 3. This one is not. This vertex is also 1, 3. It's not 1, 3. So your first and your fourth for this guy don't really work out for you. So now we just would need to look at our top graph and our bottom graph. Based off of this negative sign, we can prove that the graph should be opening down. So this would be our correct answer. Okay, and that's what we have for our review. If any questions come up along the way, you should be able to refer back to this and do pretty well. So best of luck to you, and I'll talk to you soon.